Students, now I am going to derive the relation of hydrostatic pressure and center of pressure. Okay, so hydrostatic force of submerged body. Okay, there are two cases. For this. Okay, one case is when the plane lamina is 90 degree to the free surface. Okay, this is, let us call it as free surface. That is, plane lamina is 90 degree to the free surface. Another plane lamina is inclined at angle theta to the free surface. That there are two cases. Okay, so case number one. Case first, I am giving you the question. A plane lamina is submerged into fluid. Find the lamina is making 90 degree to the free surface. Okay, find out number one, hydrostatic force acting one side of lamina, okay, and center of pressure. Okay, as I told you, there are two cases. In this session, we are going to derive the relation of hydrostatic force of the submerged body when the body is making 90 degree to the free surface. Another case will be that plane of the lamina is making 90 degree, inclined at angle theta to the free surface. That we have to find out in case 2. Case 1 is plane of the lamina is making 90 degree to the free surface. Okay, so and hydrostatic force acting on the one side of lamina. Another is center of pressure also. Center of pressure, I will define what is that one. So see here, let us call it as free surface. Okay, this is called free surface, and lamina is like this. That is this one at distance y from the free surface. Okay, so let A is the area of submerged body, okay. Y bar is the distance of center of gravity, centroid from free surface. Okay, H bar will be equal to distance of center of pressure from the free surface. Okay, so this area is, let us call it a delta A, center of gravity point G, and center of pressure will be C. So as per assumption, we are calling it as Y bar, that is free surface. Okay, that is Y bar is the distance of center of gravity from free surface, and this is H bar. H bar is distance from the free surface to the center of pressure. Okay, now we have to find out the force first. Thereafter, we have to find out the value of H bar. Okay, here also I have put it H bar. Okay, so H bar is distance of the center of pressure from the free surface. Okay, so now let us consider, we have to find out the hydrostatic force. Okay, so this is elemental area. Consider elemental area consider an elemental area of delta A. Okay, so pressure will be, as we know, P is equal to gamma into H. So gamma into H is, instead of gamma, H here Y. Okay. Now force of pressure is nothing but hydrostatic force. Okay, that is pressure into area. So that is gamma into Y into delta A. Okay. So see here, this is nothing but gamma into delta AY. Okay, that is pressure into area. Now we know that Y bar is equal to A1 Y1 plus A2 Y2 by A1 plus A2, that is centroid. So it is integral form, delta AY by A, that is integral form. Okay, that is Y bar. So this delta AY will be equal to, that is force of pressure. Okay, so P is equal to see gamma into delta AY. Delta AY is nothing but AY bar. Okay, so this is the formula to find out hydrostatic pressure. This is the formula to find out hydrostatic pressure, hydrostatic force of a submerged body. Okay, submerged body. Now second part, we have to find out center of pressure. See, this is the system. Okay, that is the system. One system is there and number of forces are acting there. If that number of forces are replaced by a single force, that force is called resultant force. Okay, so let us call it as, here this is delta P. Okay, and here it is P. So at centroid, what the force is acting, that force is this one. Okay, so P is equal to AY bar gamma. Now we have to find out this one, location of center of pressure. So center of pressure is, when the body is submerged into liquid, a point in the surface where resultant hydrostatic acts, a point on the surface where resultant hydrostatic force acts, that is called center of pressure. Okay, so center of pressure equation we are going to find out. See here, this one, this force delta P, okay, is nothing but P is equal to gamma into Y into delta E. Okay, that I have taken from already derived equation. Now what is this? See, this is the force, no? And moment of the force, actually it is delta P. Okay, so this is delta P. So moment of delta P about, this is called free surface. Okay, about OO will become delta P into what is that? See, delta P into Y. So it is Y, it becomes gamma into Y square delta A. Okay, so it becomes gamma into delta A square is equal to IgG. Okay, that becomes moment of inertia passing through the centroid. Okay, and this becomes, this equal to, now at the P, so P into H bar will be equal to gamma into IgG. Am I right? So H bar will be equal to gamma into IgG by, see, P is nothing but AY bar gamma. Am I right? So this gamma will get cancelled. Now what will be happen? So better to write here, this is, space is less here. So see here, P is equal to AY bar gamma into H bar will be equal to gamma into IgG. Okay, so this gamma will get cancelled. So H bar will be, this one will be IgG by AY bar. Okay. Then if we convert this one, H bar will be IgG is equal to, that is AY, or equation becomes Y bar plus IgG by AY bar. This equation is going to give you center of pressure equation. Okay. Rest of the thing I will discuss in next class. Thank you.